Hi, my name is Alex Fleischman, and welcome to the video overview of the simple pendulum demonstration. Let's go over what's going to happen during this demonstration. This demonstration will allow students to compare an experimental and theoretical value for the period of a simple pendulum. Let's review a couple principles. Period. Period is the time it takes the pendulum to make one full revolution. That means if it's starting on the right, it goes to the left and back to the right. Let's now go over the equation for period. Period is equal to 2 pi, the square root, the length of the string, over the acceleration due to gravity. Let's start by finding experimental values for the period of a simple pendulum of equal length, in our case 0.2 meters, but different mass heads, in our case 0.2 kilograms, 0.3 kilograms, and 0.4 kilograms. A couple of my students found that on 3 separate trials the period was 0.95 seconds, 1.01 seconds, and 0.98 seconds respectively to each mass. So now the question is, what can we infer about the relationship between the mass of the pendulum head and the period of the pendulum? Well, this is where we get our equation. Period is equal to 2 pi, the square root of the length of the string, over g. Theoretically, period is only affected by a change in pendulum string length, L. Now let's calculate our theoretical period by plugging in 0.2 as the length of the string. Our theoretical period in this case is 0.98 seconds. Now let's calculate the average experimental value. That value is 0.98 seconds. And the theoretical value we just calculated before was also 0.98 seconds. So in the case of our experiment, the average experimental value with respect to the theoretical value is a 1-to-1 ratio. Let's review what happened in today's demonstration. Well, the period equation is period is equal to 2 pi the square root of L over g. And note, period is only affected by the length of the pendulum string.